Okay, we're live. I'd like to welcome Tallbloke here. I don't know how to pronounce your last name correctly. I'm going to let you do that. But I'm super happy to have you here. I know you've been a longtime climate skeptic, and I've been a reader of your stuff for many years. So it's a great for me to actually see you over Zoom.
Well, Tom, thanks for inviting me onto your podcast, and likewise, it's great to see you face to face after all these years that we've been
Yeah.
following each other. And I've loved following your dry wit and humor,
Well, thank
and
you.
the way that you conduct yourself on Twitter, particularly, I think
Okay.
is great. So I'm pleased to be here. It's great to talk. It's such a huge subject. I
Mhm.
mean, I should start off by saying a little bit about myself for your
Yes.
viewers who don't know me. So yeah, known as Tallbloke on the internet because I'm 6'8". My name is Roger Tattersall, and I live in northern England, just sort of out on the edge of the countryside, on the outer edge of one of the bigger cities in northern England.
Okay.
And I love it here because I can hop on a train that's about 10 minutes walk away, and within 15 minutes, I can either be in the city centre or 15 minutes the other way. I'm in the gateway of the beautiful Yorkshire Dales, which is a hilly area of great natural beauty where I love to go walking, backpacking in my spare time, camping out in nature and just enjoying that kind of thing.
So is that from All Creatures Great and Small? Is that where that was?
That's right. That's right.
Oh,
Yeah, the
yeah.
Yorkshire Dales. Yeah.
Yeah, we love those books. We read them and talked about them. I wanted to visit that sometime. It must be great just to see it in person.
Tom, come on over.
Yeah,
Come on
I
over,
would love
my
to.
friend. I'll be my pleasure to
Uh-huh.
take you on a tour of the
Yeah,
region, show you how beautiful my home county of Yorkshire is.
I would love to do that. Fantastic.
So yeah, I'm been a long time had a long-term interest in science, as you mentioned.
Mhm.
I started out when I left school at the age of 16. I went into engineering and I did day release to college and gained some higher national qualifications as a production engineer.
Okay.
Um, a few years later, I suffered a back injury at work and I had to go leave the work I was doing because I'd been doing heavy machining work in the engineering industry. I actually machined some of the core components of the CERN particle accelerator all those years
Mhm.
ago,
Really?
and
Okay.
so it's quite interesting stuff. But so I thought, well, now's my chance to go to university and broaden out my outlook, learn something more. So I intended to do philosophy and computing, but the computing department guy who was interviewing me, who was a professor of statistics, he said to me, I said, "Oh, I see you don't have an A level in maths." I said, "No, I left school at 16. I went in engineering. I got my higher national qualification in maths, which is in advance of A level standard." And he said to me, he said, "Well, he said we once had a polytechnic student here a few years ago, but he left after a few weeks."
Oh,
And there was this kind of silence, and I said to him, I said, "So you're a professor of statistics, and you're basing your judgment of polytechnic students on a sample of work?"
wow. That's pretty
And
funny.
and so yeah, that was the end of that interview. So I ended up doing a joint honours degree in philosophy and the history and philosophy of science, and it's the most interesting course I ever did, and I'll never be bored again. I've got a lifetime of things to think about through doing that. I learned about the
Good.
history of medicine. I learned about
Mhm.
how scientific theories are evaluated.
Mhm.
I learned, the history of the development of European science from the time of the Greeks, right through through the sort of Enlightenment period,
Mhm.
and up to the present day. And it was a real eye opener for me because what I realized was that most scientists don't get that broad based
Mhm.
grounding in understanding
Yeah.
their own their own field, science as a whole. They tend to fairly quickly become specialized.
Yes.
They're led into quite narrow areas of research interest, and so they kind of don't see the wood for the trees in a lot of ways, and that's something that we can discuss during
Yes.
this hour because it's very important to realize that a lot of scientists don't actually understand what science is all about and
Mhm.
how it should be conducted, and how you get the best results from doing science. And this is of crucial importance to our society as science has become so important in underpinning policy decisions
Yeah.
and the way that we use knowledge to shape society and the world that we're creating for the future. So that's a sort of broad kind of introduction to me and what I'm, I could go on just to say a little bit more about,
Yeah.
where I've been and what I've done
Let's do that.
in relation to the climate debate. And,
Yeah.
and that is that I finished the last year of my degree was in 1988, which of course was the year that Jim
Oh,
Hansen
yeah.
gave his testimony to Congress on that famous hot summer's day when his sidekick Tim Wirth had left the windows open so the aircon wouldn't be effective, and the place was roasting and everybody was dripping in sweat. And Jim Hansen was telling everybody what a big problem carbon dioxide emissions were going to be, and that kind of seemed to be a kind of real start point of where the popular, publicly aware climate debate got going. And I was there at the start, and
Really?
I kind of looked into the claims he was making and thought, there's quite a lot to unpack here. And obviously, when you've done a degree in the history and philosophy of science, you're taught how to go to the sources, download the data, verify things for yourself, look at the theory that's being generated, and make assessments of what you think the quality of the data is, how much uncertainty there is in the formation, the way the theory's put together, and all these things. And at that time, I thought, well, it all looks a bit uncertain to me, but it's not having any great impact on society at the moment. But fast forward on 10 years, and it started having a big impact on society. And if you fast forward to now, we're absolutely in a phase where government policy, as it applies to cutting emissions, threatens the very economies that the world depends on for the well-being of billions of people, all of us. And so this has now become a crucial debate, and one that's been sadly biased and contained and demarcated by people who think that you should only be hearing one side of the argument. And this is a huge danger to us all. It's not the way that science was ever designed to proceed. Science was always designed to proceed on the idea that you put up a hypothesis, and then other people try to find counter evidence to show that the hypothesis is wrong, and then come up with better hypotheses, and so on, and develop forward through that kind of dialectical process to get a better handle on how the world works, and what knowledge we can apply to the way that we run the world, the way that we run the human world. And this has been kind of stalled by this quasi-religious faith in the science, capital letters, whereby people who are skeptical of the theories are censored, shut out, suppressed. They don't get any funding for research, and all these sort of biasing situations that prevent proper scientific progress. So we have a huge amount to cover in this discussion that we're going to have together today. But I just wanted to lay out that to start with, just to kind of widen the whole thing out beyond discussion of the finer points of what carbon dioxide does and doesn't do in the atmosphere, and these kind of specific issues.
Okay.
So over to you. Lead me on.
Well, I am very interested that you were a climate skeptic back in 1988. So I was just doing the math in my head. I think you've been a skeptic for about twice as long as I've been a skeptic. And for all that time, up to like 2005, I was a casual believer that I just thought, oh, the scientists, they say it's dangerously warming. They must be right. And like I've said, I didn't do any climate marching or anything, but at that time I was naive, and I thought the scientists, they know more than we do, blah, blah, blah. I'm curious though, what it was like to be a skeptic in the 1980s in terms of there was no Twitter around, and how did you talk to other climate skeptics? And I actually wanted to go back even before that, I don't know if you were during the global cooling scare, if you were thinking about that, or I don't know how old you would have been then, but I can remember it. Yeah.
Yeah, I mean, the global cooling scare, I mean, I was fairly young at the time, but I
Mhm.
was out and about,
Okay.
because I've always been a keen hill walker and backpacker
Mhm.
right from my early teenage years.
Yeah.
And when I was 13, myself and another 13-year-old friend, we did a 270-mile
Mm.
walk up the backbone of England, up the Pennine Hills,
Okay.
on a long distance walk called the Pennine Way. And and that was in the hot summer of 77, and the previous summer, 76, had been even hotter. They were remarkably
Mm, yes.
warm, dry summers in the UK. And so that was interesting. But also in the 1970s, there were some really severe winters and a lot of colder weather too. So it's kind of anecdotal. It's hard to draw any firm conclusions at this kind of distance in time,
Mm.
and how your perception changes from when you're a very young person to when you're a more mature person. But but I do remember, the snow being on the ground for weeks at a
Mhm.
time in northern England when I was walking to school as a 7, 8-year old. So that would have been in about 71, 72.
Okay.
And this was around that time that there was a lot of really serious concern, including from the CIA in America. They commissioned a big
Yeah.
report on this.
Uh-huh.
They were very interested in what the possible effects were going to be on crop production,
Mhm.
whether this might cause civil unrest, and so they were obviously taking the issue seriously. There are hundreds and hundreds of articles at the time
Mhm.
talking about this big drop in temperature.
I
And
remember that. I'm sorry. I remember that being on the farm. I was growing up on a farm in the 70s, and those winters in Minnesota, they were very cold. I think our old farm thermometer said 40 below multiple times, and we had to
wow,
work hard to keep the pipes from freezing. The cattle were indoors, and the water pipes wanted to freeze because it was really cold in those winters. And I thought that there were anecdotes about there was some snowstorm in Cleveland where they were driving snowmobiles past the chimneys of houses. That there was just enormous amounts of snow, unbelievable. And I think that fed into the whole global cooling scare, but that went away, as you said. Yeah.
yeah, it was a real thing though, and
Yes.
and as we found out recently, and this is an interesting bit of science just to go into now for your listeners to get hold of. If they look at the moment at my blog over at tallbloke.wordpress.com, Tallbloke's Talk Shop as I call it,
Okay.
they'll find that pinned at the top of the blog at the moment is um, I'd say it's almost a scientific paper. It's kind of there for open peer review. It's been written by Ned Nikolov and Carl Zeller, and it's about a data set which was published last year uh, for solar surface radiation. So this is different to how much sunlight arrives at the top of the atmosphere, which is what the climate scientists always say is pretty constant and doesn't vary much, doesn't vary enough to be climatically important. But this data set is taking all the readings and measurements that have been done over the years, and creating a spatial grid and weighting those readings to get a better idea of what was happening globally over land, not over the ocean, because they
Okay.
didn't have these
Mhm.
measurement stations on the ocean, um, but over land, the amount of sunlight actually reaching the ground, actually reaching the Earth's surface. And it's a very interesting result because what it shows is that there was a very profound and big drop of around 8 watts per square meter from about 1962 to about 1974.
Hmm.
Now, that's a really big figure, when you compare it to the heating power of that's ascribed to carbon dioxide.
Hmm.
Um, they're talking about, I think, 3.7
Yeah.
watts per doubling of carbon dioxide. But this is an 8 watts per square meter drop
Interesting.
in
Hmm.
in the amount of solar radiation reaching the Earth's surface. And if you work out the sensitivity, not of the Earth's climate system to carbon dioxide, which has been, we believe, probably overestimated, and
Mhm.
it's gradually come down over
Yes.
the years, and they keep saying, oh, maybe it's not quite as much as we thought,
Hmm.
but they still say it's probably in the region of 2 centigrade for a doubling of carbon dioxide. But if you look at the climate sensitivities of other climate factors, such as the shortwave radiation from the sun that reaches the ground, you find that could have caused a drop of several degrees putatively. Now, this would likely be ameliorated by the massive heat capacity of the ocean, that when the Earth started getting colder, then you would get more energy coming back out of the ocean because you'd have a greater differential for conduction between the surface of the ocean and the air. And the air only has as much heat capacity. The entire atmosphere only has as much heat capacity as the top 2 meters of the ocean.
Okay.
The ocean's kilometers deep.
Okay.
So you can appreciate that there's an awful lot of energy stored in the ocean. And when it gets the chance to come back out, it can soften the changes that you otherwise might expect from a change in a variable such as this solar surface radiation variable. But of course, the question to be asking ourselves about this variable is, well, what caused the amount of sun reaching the surface to change? And the answer is cloud albedo. So what we're saying is that the amount of cloud covering the Earth increased probably by several percent during that period through the 60s into the 70s.
Okay.
Interestingly, from the end of the 80s, the amount of cloud started falling again, and that's really what caused the warming since then. Is not an increase in carbon dioxide, but a reduction in cloud albedo. And the climate scientists know this, but they don't ever tell the public about that because it makes the story too complicated. They want to say, oh, more CO2 creates this blanket that traps heat, and that makes the Earth warmer. And give us this really simplistic sort of idea of how the greenhouse effect works, as they call it. But in fact, they know as well as we do that it was additional solar radiation getting to the surface that actually caused most of the warming. But they try to explain it away by saying, oh, well, that's just a feedback to the increase in temperature caused by the increase in carbon dioxide. Now, we've no particularly good reason to believe them about this. It's an ad hoc hypothesis that's been added on to their theory. And as a historian and philosopher of science, the history of science is littered with people making stuff up as they go along to try and explain, new discoveries or things that have come to light that seem to refute their original hypothesis. But unfortunately, we now live in an age where it's so difficult to get this kind of stuff published that they can get away with still putting out the same old story of that carbon dioxide is a blanket trapping the heat, and that we're increasing carbon dioxide, and that's what's making things hotter. So there is a lot of debate to be had around newer data which has come to light or been recorded since the science was settled by the IPCC back in the early 2000s.
So this paper on your blog, is that related to the work of Nir Shaviv when he's talking about the cosmic rays changing the cloudiness of the Earth? Does that sound similar to me? Yeah.
It could be. It's kind of independent of that question of what causes the change in the cloud cover. Okay. This is just an empirical analysis of the data.
Yes.
But certainly in the longer term, when you look at, in what we believe in the right way of looking at the data, taking into account the massive heat capacity of the ocean and the amount of change in the solar variation, it seems likely that there is a solar effect on cloud cover. So when the sun gets stronger, it chases away more of those cosmic rays that Nir Shaviv's talking about that get into the inner solar system and into our atmosphere and seed the clouds. And so you get less cloud. And also confirming that would be, quite long-term reconstructions of solar activity and longer-term proxy reconstructions of temperature, which show that there is, a long-term relationship between the sun's activity and the surface temperature on Earth. So, it's not so easy to tie down at the sort of interannual or decadal scale, but you can see looking at longer term data sets, you can see that there is a relationship between the sun and our climate. And that's probably amplified by the sun's effect on cloud cover. But it's not a sort of simple, immediate one-to-one relationship. There are obviously complex things going on that need more, as always, more research needed. But we can get a sense that in the past, it's quite clear that the sun had a strong effect on climatic variation, and there's no reason to suppose that the sun went on holiday and stopped affecting climatic variation just because we started putting out a bit more carbon dioxide after the Second World War. So, this is getting into the skeptical side of the argument and saying, hey, let's look at natural variation, because all the variation we've seen so far is within natural limits after all.
Yes.
So we shouldn't be presupposing, as the IPCC has, that there's a human fingerprint on climate change and global warming.
Okay. All right. Do you have any sense at all? It's probably too early to ask this, about what you think is going to happen in the next 20 to 40 years on Earth. Do you have any predictions at all, or is it so complicated that nobody knows?
Well, we over at the talk shop, we have had a stab at making a couple of predictions
Okay.
about solar variation, and I produced a semi-empirical model back in 2011, I think, predicting what if we're right about what we're predicting for solar variation, what effect that might have on sea surface temperatures and therefore global surface temperatures
Okay.
out to 2050. So we've got a solar prediction out to 2100, which says, correctly, that the last cycle and this cycle are going to be quite low.
Okay.
Then there'll probably be a bit of a recovery through the middle of the century, but not back up to the kind of levels of solar activity that we saw towards the end of the last century. And then as we get out towards 2100, it's still looking, very low. Solar activity is still looking low compared to the so-called grand maximum of the 1940s to 2003.
Okay.
So, that's the solar prediction. And then the effect that has on my semi-empirical model is that I think, might see a reduction in global surface temperature, probably not more than about 0.2, 0.5 centigrade
Okay.
between now and around 2050.
Okay.
So not a big deal either way. I'm not going to lose sleep if it turns out I was wrong, because half a degree is barely measurable and really has very little effect on the Earth and its population of animal species, including ourselves. Human beings are quite capable of living anywhere temperatures anywhere between -40 and +40 all over the world, from the equator to the poles, and so many other species are able to migrate, and they'll choose where to go, where they feel that the climate's temperate for them and the way they live. So I think that the Earth and its creatures are a lot more resilient and able to cope with change than the kind of horror stories that are painted by the more alarmist part of the warm part of the debate.
So you don't think it's going to just be a linear rise from here to 2100? We're going to see another 2 or 3 centigrade warming? I don't think we are in the next 80 years, but
No, I don't think so. I mean, if you look at the long term, because another thing that I'm very interested in, is that you've probably spotted over the years, is that I'm very interested in cyclicities in climatic variation. For reasons that we might go into later on in this chat, but for now, we'll just say, there have been identified some quite long-term natural cyclicities in climatic variables, and one of those is what's called the Bray Cycle. It's about 2,500 years in length, and it last reached a low point sort of in the depths of the Little Ice Age, kind of in the early 1700s. And so for the next 1,200 years or so after that low point, we might expect things to gently warm up, with some ups and downs and excursions along the way caused by other shorter term cyclicities in climatic variables. But that's the big long term picture, if you like. So it wouldn't shock me and surprise me if things kind of got warmer again after this kind of low solar activity period that we're going through. That if things cooled down to 2050, as I predict they might, and that then they started warming up again for several hundred years more. May well be the case. We don't know. We can't see that far ahead. Anybody who says that they've got a solid prediction at that kind of distance, I think, is deluding themselves and anybody who thinks that they should listen to them. But
Okay. I have a question here. If you start at the depths of the Little Ice Age and go back in time, how far back do you have to go until it gets that cold again? I mean, it was really cold on a
it's
perennial basis, or
it's possible that it wasn't that's the coldest it's been in the Holocene. We don't know for
yeah,
sure, but what we do know is that the temperature in the warm periods was quite a lot higher way back in the Bronze Age, sort of 8,000 years ago, and it was warmer during the Roman climatic optimum 2,000 years ago, and it was warmer in the medieval warm period,
okay,
sort of 800 to 1,000 years ago. And so what we're seeing is what we've seen from our proxy variables telling us about climate from previous interglacial periods, that we get these periods of glaciation and interglacial periods rolling round about every 100,000 years. And what tends to happen is when it comes out of glaciation, the temperature goes shooting up, it reaches a maximum, and then it tails off, and then eventually starts to drop more steeply into the next glacial period. So it's quite likely that the Little Ice Age was as cold as it's been, since the previous deglaciation 120,000 years ago.
okay. I just saw something about how possibly cooling could advance so quickly that a local area would go from oak trees to tundra in 100 years. Have you heard something about that? That seems pretty fast to me, but I don't know.
Yeah, I suppose that there was a period of glacial advance during the Little Ice Age in Central Europe, so
Okay.
in Austria, Switzerland, in those mountainous regions, and some of those glaciers grew and advanced pretty rapidly, and actually, raised entire villages to the
Yeah.
ground. So, it shows you that, yes, everybody's worried about glacial retreat at the moment, but glaciers can advance as well as retreat, and have done in the relatively recent past. Certainly in the time of recorded, well and accurately recorded history over the last few hundred years. So, we should expect
Mm.
variation. How quickly the onset of a serious glaciation, as in, if we really were to start dropping into the next
Mhm.
80,000 years of glacial period, um, I don't think anybody's got a definite answer to that. And I'm always wary of ideas that involve things called tipping points,
Yes. Yeah.
because I think people like to come up with dramatic and powerful narratives, partly to draw attention to themselves and
Yes.
get more attention paid to their ideas, um, and partly because for some reason human beings have this kind of uh, inbuilt worries about apocalyptic events
Mhm.
happening, the possibility of them, and predicting them, and fearing them, because after all, we live in a world that's ever changing. Climate has actually been remarkably stable and
Yes.
benign
Yeah. Mhm.
over, for as long as we've been measuring it, really since the middle of the 1850s, compared to what it has been in the deeper past.
Mhm.
And we know that there have been things like great floods and inundations that wiped out, civilizations, that put their cities underwater off the coast of India and other places in the past. And so humans rightly, fear sudden cataclysmic natural changes. But a lot of times you find that these natural changes were caused by things like undersea earthquakes
Oh, okay.
or huge volcanic eruptions. And while they can be very devastating for quite large populations in a regional part of the planet, we're not talking about the longer and slower climatic changes, such as the descent into the next glaciation. So I tend to be a little bit wary of apocalyptic ideas about how fast things could turn
Mhm.
to icy windblown tundra
Mhm.
from the green and pleasant land that we enjoy in the temperate parts of the earth today.
Okay. Do you know something about how around the year 536 or so, the earth went dark? I just heard some mention of that. I don't know if that was a volcanic thing. I hadn't heard about that till last week or so. Somebody mentioned it on a podcast. That,
Yeah, I mean,
yeah,
I don't know much about it,
yeah,
honestly. So not really my area of study, but I
yeah,
suspect it quite probably was linked to some serious volcanic activity.
yeah,
You know, if it turned the sky dark, then you
mhm,
might expect that,
yeah, mhm,
because volcanoes, when they put out stuff that goes right up into the stratosphere, that
yeah,
can get spread around the whole planet.
mhm,
And we had that thing in, I think, in the early 1800s, known as the year without summer, that
yes, yeah,
followed a major volcanic eruption as well.
okay,
So, I think that's probably the answer to that. But it's worth noting that um, some of the biggest volcanic eruptions have happened when the sun has been relatively inactive.
okay.
So, early 1900s, there were a couple of very low solar cycles, a couple of quite big volcanoes.
Oh,
Uh,
okay.
you know, the 1970s, okay, it was 1983 before we got the big one, El Chichon,
Oh,
let go, that they reckon caused about a half-degree drop in the Earth's surface temperature for a couple of years. And it's worth noting, while we're talking about volcanoes, if you don't mind me just digressing a minute,
no, go for it.
uh, that that in the CMIP5 climate model predictions for how the temperature is going to go in the future, they don't include any volcanic eruptions. And they say, oh, well, that's because we don't know exactly when they're going to happen. They're black swan events, so we can't include those. But you'd have thought that
Mm,
that since they in the recent temperature record, they can see that big volcanic events cause a drop in the Earth's temperature
mm,
and then a slow recovery again, that they might introduce some sort of average figure or
mhm,
some idea of how much that might prevent the temperature racing away several degrees over the next 70 or 80 years. But that doesn't fit their narrative, does it? So we're not going to see that, unfortunately.
interesting. Have you looked into Yellowstone at all? The possibility of Yellowstone to have super eruption there? I'm just curious.
I mean, I heard about that in a documentary, many years ago. I think there was a documentary shown in the UK about the caldera, the possibility that it could blow, and that the evidence that it had blown in the past showed that there was, you know, incredible ecological fallout from that, and it probably killed
Mm.
a large percentage of the human beings that lived on the continent of North America
Oh,
at that time.
hmm,
And so these kind of things put a degree of warming over a century or so
right.
into perspective,
Mm,
don't they?
they do. Yeah.
These kind of cataclysms could overtake us, and so, you know, I again, I think that the whole question about climate change, they have to make it seem apocalyptic to try and get people to pay attention to it, because if you say, "Oh, well, it's warming up a degree over 100 years," then most people shrug their shoulders and carry on with their
Mhm,
lives, don't
right.
they? They're not going to be convinced that they have to rush to climate action and accept a
Mhm,
radically different lifestyle on,
absolutely.
on the basis of such a mild and slow warming
Mhm,
or change in temperature of the planet. And so, this again all plays into the way that the media works, because the media has to come up with exciting stories in order to get the views or make the sales of printed papers and journals
mhm,
and magazines. And so they have a vested interest in amping up the stories told by climate scientists. And so we've got this kind of unholy alliance of the media, the scientists who are coming up with these apocalyptic stories, and the politicians who think, hey, we can make use of this to get a load more tax money out of the population. So, we shouldn't be surprised when these things kind of happen. But whereas there used to be some kind of checks and balances in
mm,
all of this, where you'd have dissenting sections of the media, dissenting politicians, we seem to be now into an era where uh, groupthink has become so
mhm, yeah,
entrenched, and the pressure, the peer pressure to conform to the current narrative is so strong, that people will lose their jobs if they speak out
yeah,
against it, or they'll have their funding cut, and they'll be cast out into the outer darkness from academic institutions. So it's very hard to conduct dispassionately done, unbiased, carefully researched science in such an atmosphere. And this is part of the problem, I believe, and why the debate has become so polarized and bitter.
So, don't you think that when the Earth does fail to warm as advertised, that when people do talk about it, they're going to point fingers at each other? The media is going to say, "Hey, the scientists told us it was going to be bad, and we just reported it." And then the scientists are going to say, "Hey, the media hyped it. We never said it was going to be that bad." I think we're going to see that. I don't know.
Do you know, Tom? I think that's probably the best scenario. But I think I honestly, sometimes in my gloomier moments, I think that the people involved in this would be so keen to prevent being proved wrong. They'd rather start a nuclear war.
Oh,
You know, if it was getting colder, they'd start a nuclear war and say, "Oh, it's the nuclear winter that's made the Earth
oh,
cold."
okay.
Not, you know, we're not wrong about our CO2 global warming theory. And it's because you think about the massive loss of face for all the politicians, all the science institutions,
Mm,
all of it. It's just become so huge now that what they've got invested in this, and the drastic nature of the changes that are being enforced on entire populations to fit in with their ideas, that they are mortally afraid of being proved wrong. Um,
mhm.
I think famously there was one of the ClimateGate emails least where one of the scientists said, "What if it all just turns out to be a multi-decadal oscillation? So what are they going to do? What are the public going to? They're probably going to lynch us."
Yes, yep, I saw
And
that.
you know, and that kind of sums up the kind of insecurity that
Mhm,
these scientists have about their own, because they know damn well how uncertain their ideas and theories are, and how uncertain a lot of the data is. You know, prior to the satellite age, when we started getting more accurate data, that they are painfully aware that their story has been oversold by the politicians, oversold by the media, and yet they stay silent about it. And that's, to my way of thinking, uh, unethical in terms of science ethics. It's unethical to allow ideas to be blown out of proportion when they actually know better themselves, and were saying so between each other in private, but not saying so in public.
I'm hearing that quite a bit now. All of a sudden, in back channels, or people are telling me that they know climate scientists or they are climate scientists, and they're saying, "Oh, what's being said behind closed doors is not at all what's being said in public." I guess we saw that in the climate gate emails too. But what percent of the climate scientists do you think actually have bought into it and they really think that they're saving the world? There's a certain percentage of them that actually believe it. I think Catherine Hayhoe believes it, but
Yeah,
I don't
yeah.
know. Don't know.
I mean, I don't think it's a very big number of
Yeah,
scientists. I mean,
yeah,
probably if you narrow
yeah,
down
mhm,
to the specialized field of climate science,
yeah,
and as it were, the coattailing study areas like, you know, climate impacts, and who knows what, equality and diversity in climate studies, and all of
yeah.
these sort of add-on sort of sociological type scientific areas, which kind of hang on the coattails of the whole climate scare, that they will. So it's very hard to tell whether they really believe the hype that they themselves put out there through their press releases to the media from
Mhm,
their institutions. Uh, there's probably a lot of them think, "Hey, I'm just making a really nice salary here. I'm going to get through my career.
mhm, yeah.
I'll retire." And we noticed, you know, over the previous decade, quite a number of climate scientists, when they finally retired,
Yes.
then they came out and said, "Actually, I think it's all
Mhm.
been overblown. I think they may have made some fundamental errors in
Yes.
the way that they've done the science," and so on. And those voices, obviously, we tried to amplify through through the sort of the Twitter sphere, and the climate skeptic blogosphere,
Mhm.
because they were silenced and ignored by the
Yes.
mainstream media
Mhm.
and everybody else. So it's a very uneven fight. It's a sort of David and Goliath fight we're in, isn't it? You know,
It is. Yeah.
the climate industrial complex has the whole of the mainstream media on its side, all the politicians, you know, the scientists who and the administrators who run the institutions and are fed the funding streams on condition that, the right kind of message comes back from the coalface, in these academic institutions that confirm what the politicians want to hear. And this is how we end up with evidence, policy-based evidence rather than evidence-based policy, as the saying goes. So, this is a serious concern because of the direction that it's leading science itself into disrepute.
Yes.
And this is a real big hobby horse of mine, which I'll come on to after I've had a chance, let you have a chance to say a bit more.
One thing I wanted to mention about what's going to happen in 2050 on Twitter, people were talking about how the weather's not going to get worse, and by 2050, still no apocalypse. And what they're going to say is that, hey, it was all that money we spent on this on preventing climate change. It would have been really bad, but it stayed the same because of all the heroic work we did. I think we will hear that quite a bit too.
I think we will. I mean, it'd be very easy to disprove, because if carbon dioxide carries on increasing, then but of course, you've got to remember that is measured at only a very few sites around the world, and it's measured using what they call reference gases to compare the current concentration to what the concentration is in this sort of special bottle that's been specially prepared with apparently, a specific number of parts per million of carbon dioxide.
Okay.
Now, just think about the kind of incentive there would be to fudge the figures to suit the narrative again. So, this is again going back to my training. You have to be careful when you're dealing with data because you need to know something about who's collating that data, who's theorizing about that data. If they're the same bunch of people who are collecting, curating, and theorizing about the data, then that's a big red flag because obviously there's a strong incentive on the part of the people who've come up with the theory to perhaps the data just needs adjusting a little bit, so that it fits their theory better. And if you've got all of the control of all those three things, the curation, the obtaining of the data, the curation of the data, and the theorizing about the data going on in one big institution, then there's far more danger that something like that could happen. And it's just human nature. I mean, I'm not being particularly mean to climate scientists here. This kind of thing goes on all over the world, everywhere, all the time. It's human nature. And if you look at more mature disciplines, such as, say, civil engineering, then the data is collected by one organization, it's looked after and curated by another, and the people who built the bridge don't get to change the data, because if the bridge collapses, then there's got to be a chain of custody on the evidence that can say who's at fault, if something like that happens.
I wanted to make a point about CO2. What do you think about these CO2 measurements prior to 1950? There's all sorts of these chemical measurements, maybe even in the 1800s that were 430 ppm or more. And they just threw those out, I guess. I don't know why they threw those out. I have that question. And then going back to the ice cores, and we're supposed to believe that CO2 was stable for maybe hundreds of thousands of years or a long period based on how much CO2 is in these ancient ice bubbles. I'm not believing that one either, but wanted to know your take on that one.
Yeah, well, I think the guy was called George Ernst Beck, who collated all these old CO2 measurements that had been taken around. And obviously you can think that there might be quite a lot of experimental error involved. Again, for all of those readings, you didn't have full information maybe about where they were taken, what time of day they were taken at, what the sort of environment was that they were taken in. And so you're obviously going to have a bigger spread of uncertainty on that data. But even when you throw out the outliers, they show that CO2 was a lot more variable, and variable in tune with temperature variation in the past than this record that's been created from this splicing together of ice core data with modern instrumental measurements taken from Mauna Loa and elsewhere after 1958. Okay. And my view on the ice cores is that due to diffusion of the gas through the ice, that's going to act like a smoothing, which will take out the peaks and the troughs in changes in CO2 in the past. Now, interestingly, there's another way of looking at this, which is to look at fossilized leaves,
Okay.
because leaves have things called stomata on them, which are like little pores into which CO2 can get, and the plants need that because CO2 is plant food. You know, it's what they create. It's what through the process of photosynthesis, it's what they create the sugars with that enable the plants to grow. So those stomata, the number of them, you know, sort of the number per square centimeter or in different species of trees is different. But when you look at the same species over a long time, you can see that number of stomata varying in proportion in very similar way to the way that the information collated by George Ernst Beck has variation on the multi-decadal scale, and also, you know, much higher peaks in the past. So it does seem likely to me. I mean, that the Dutch guy whose name temporarily escapes me, the scientist, what's his name now? It might come back to me while we're talking, but he presented this, and they immediately buried it, you know, and they said, "Oh no, that can't." So again, it didn't fit the narrative. It was shoved under the carpet. But it's another line of evidence which shows that CO2 was a lot more variable in the past than the record which is used by the IPCC for their narrative shows.
Okay. So this whole thing again about the ice cores, I'm obsessed by it. That the story is that we have this air bubble that's 700,000 years old, and it has exactly the same proportions of CO2 in it now as it did on day one. That's the story that we're supposed to believe, isn't it?
But yeah,
preposterous. Yeah,
it is preposterous, and I think, you know, we can safely discount it, and it's still used, as you know, to present the overall argument that the IPCC is presenting, that the climate was very stable and didn't change much in the past, and it's warming rapidly due to our activities. But you know, if you're going to splice together two data sets, you cannot, just like with the hide the decline issue with the tree rings being spliced onto the modern temperature records, you know, it's a totally invalid way of doing science. It is, let's call it what it is. Let's not mince our words. It's scientific fraud.
Yes.
Scientific fraud.
It is.
And this is one of the things we're up against is this kind of state-sanctioned scientific fraud that we're being beaten over the head with. And it's an absolute blot and a stain on the reputation of science.
Are you familiar with this XKCD cartoon? It's a very long cartoon showing exactly that global temperatures were very, very stable for a long time period. And Gavin Schmidt said he really liked that cartoon because it showed how stable everything was until humans arrived. But then I think it was based on the Marco data, and there was some deal there where it didn't show any variation at all on like a 300-year time scale. So I don't know how you'd even draw a graph that's 6 inches long that's supposed to show all the variations over the last over hundreds of thousands of years. Of course, the 30-year variability is not going to be in there. Not that.
Of course, that's absolutely right, and this is why they tend to use, you know, the Antarctic ice cores as the reference for this, where things are more stable, because it's the northern hemisphere, it seems, where the climatic data is more choppy, you know, and the actual variations in temperature are more choppy, as indicated by, you know, the Greenland ice cores, which show big steep variations on just as short timescales as we've seen in the modern era. From thousands and thousands of years ago, which sort of makes you question, well, if we've seen bigger natural variations back from when before, you know, Henry Ford started building big SUVs, then you know, what was the cause of that? You know, what caused that climatic change? And of course, that doesn't fit the narrative, because the narrative has to be that CO2 is the climate control knob.
Yes.
And everything else is just, minor feedbacks to the variation in CO2 causing our climate to change. It's ludicrous.
Do you agree that CO2 itself is supposed to be evenly distributed all around the globe, that it's supposed to be the same number everywhere? I've heard that. I don't know if we know that, or. What do you
Well,
think?
they say that it's a well mixed gas,
Yeah. Okay.
which kind of may be fairly true, um, up on the side of, thousands of feet up on the side of a mountain, in the middle of an ocean where everything's had a chance to mix in the air and
Yeah.
get blown around the planet.
Yeah.
But certainly, if you go into a cornfield that's
Mm.
growing verdantly, in the late spring, under a warm sun with plenty of evaporation going on as well, then you're going to see lower levels of carbon dioxide where it's being rapidly absorbed by those rapidly growing plants,
Hmm.
and probably an elevated level of oxygen being emitted by those plants. So I'm not an expert in this field. I'm not going to
Oh.
start speculating,
Oh.
but it seems to me that carbon dioxide is the most misunderstood, vilified, demonized trace gas in the history of the world. And we ought to look at a few of its good points, as well as worrying about what perhaps could be its bad points, if you believe the climate theory that's currently dominating climate science. So some of the good things. Sorry, go. Sorry,
Oh,
go.
I have something before you move on about Will Happer he talks specifically about that cornfield example where he
Right.
says on it when it's growing, it's maybe 400 parts per million at the start of the morning. He says it can drop to 200 parts per million as the corn sucks down everything that it can. So a
Yeah,
huge variation within one morning. So this whole
yeah.
idea that the CO2 is it resides there for millennia, or maybe just it resides there. If you drove your car by, it might be back in out of the atmosphere in an hour or something. Yeah.
That's right. I mean, I think the e-folding time is more realistically
Yeah.
probably a few years rather
Yes.
than
Yeah.
the centennial or even millennial kind of periods of time that the IPCC wants to convince us that our
Yeah.
awful, dirty emissions are going to be in the sky for.
Right. Okay.
And again, they love to complain. They talk about carbon emissions because it makes people think of black, dirty
Yes. Yeah.
particles, soot, stuff that's bad in your lungs, stuff that you wouldn't want all over the outside of your municipal buildings downtown.
Hmm.
And they conflate carbon as in soot with carbon as in this colorless, odorless trace gas that's absolutely vital for life on Earth, and
Hmm.
is on the whole a good thing. We've seen, as NASA showed back in 2015, they said, the Earth's got about 30% greener over the last few decades because of the increase in carbon dioxide. So the deserts are shrinking. What's not to like? Crops are more abundant. What's not to like? Um, and so, on the counter side, if the other people on the other side of the climate debate say, but what about the warming that it's causing? That's dangerous. Then we should stop and ask, well, how dangerous is this warming? Given that 20 times more people worldwide die of cold-related
Hmm.
problems than heat-related
Huh.
problems, how can you explain to me, please, what's so dangerous about this warmth? If things have got a bit warmer, and especially most of the global warming seems to have happened at night time,
Hmm.
so it's not causing higher temperature extremes in the day, but most of it's at night. Well, if the nights are warmer, less people are going to die in the night of cold-related
Right.
problems.
Right.
And what's not to like? Well, I suppose people who think that the population of the Earth is much higher than it should be, um, they might not like that. They might not like that. And I always hesitate before getting into that part of the debate about uh, overpopulation, alleged overpopulation of the Earth, and what we must do to use less resources and so on and so forth, because I think that nature kind of controls these things itself. We don't need to interfere too much with that. The Chinese had their one-child policy for a few decades and then reversed it,
Okay. Yeah.
um, and so on. But that's a whole area that's becoming more worrying and troublesome as time goes on, because the shrill shrieking from the alarmist camp is actually getting serious about this stuff. And the actions of our governments at the moment in reducing fertilizer production
Hmm.
and so on,
Yeah.
in what seems to be a concerted effort worldwide,
It does. Yeah.
is worrying. Now, obviously, that reduction in fertilizer consumption is partly due to the limited availability of natural gas in the
Yes. Yeah.
marketplace at the moment, mostly due to these this trouble that's going on between Europe and Russia at
Hmm.
the moment, and the US and Russia. But, there's also a shortage in gas supply that had started well before then,
Yes.
because we've been conditioned to believe that we must leave it in the ground. We mustn't develop these resources in the first place. And so this is to what I call the politics of scarcity.
Yes.
And it's almost an entirely bad thing dreamt up by politicians to give them more power over the populations that they're entrusted with governing well, and which they fail very badly to do. But, hey, we're heading off into politics. Maybe let's just take a minute or two's break.
All right, we are back. Go ahead.
Well, Tom, we need to talk more about the science,
Yes.
because the science itself is fundamentally important. And if you don't get the science right, and then you make policy on the basis of that science, you end up with bad policy and bad outcomes for everybody, especially on something as far-reaching as this question about climate change, whether it's human caused or not. And I think that when you look at it in the round, you've got to make sure that all points of view are heard, and that you have proper debate around these questions, because otherwise science cannot proceed in the way that it should. So as we said right at the start of our chat, science proceeds by people putting up a hypothesis supported by the evidence that they found, and then other people may be saying, hang on, that's not right. You haven't included these other factors. You haven't thought about this. What about this other data that you haven't looked at? We've got a better hypothesis that encompasses what you're talking about, but also these other factors, and gives us a better picture of what's going on. Now, that debate has been squashed over the last 20 years. And this is a serious problem. And any government that doesn't recognize that it's a serious problem is a government that you shouldn't be voting for. You do not want those kind of people in government, because science has become the arbiter of truth in the world. It's supplanted religion, since the middle of the 1800s. Science has become more and more the thing that people trust to get at the truth about how the world is. And at the end of the day, if politicians misuse science, if they deliberately bias the way that it's produced and the ideas that flow from it in order to suit a political agenda, then eventually a lot of people will stop trusting science. And where do you go from there? Religion's no longer trusted. If science is no longer trusted either, then all you're left with is ideology. And what you end up with is conflicting ideologies, and that leads to violence. And I think all of us, all sensible individuals want to live in a world where there's less violence, not more.
Yes.
And so it's incredibly important that our social administrators, that our elected officials, that our the people who manage academic institutions recognize this basic fact that you have to have open debate in order to have valid scientific progress. And this is just incredibly important. And when I started my blog back in 2009, I put out some fairly, some people say wacky ideas. Is the Earth and its temperature affected by not just the sun, but the motion of all the planets in the solar system? I kind of looked into the data there, and I wasn't trying to say this is correct. You must all now listen to me. I was just putting ideas out there for people to comment on, think about.
Good.
And so it's kind of cutting edge citizen science, if you like. And questions, how much does the moon and the tides affect climatic change over quite long periods of time? Because the moon has some short-term cycles, like it goes around the Earth once a month. Also has, sort of an 8.5-year cycle of the position of where its perigee is, going, and an 18.5-year cycle of the nodes and the tilt, sort of relative to the Earth's equator. and this does make a difference to the way that tides operate. So I was looking to see if there were any climatic signals to be found there. And this led on to a whole burgeoning field. There were so many interested people who came to talk on the blog, with bringing other ideas and knowledge. And it's been an absolute fantastic voyage of discovery, looking at all these possibilities that has led to a few published papers here and there, ideas that were started out on Tallbloke's Talk Shop,
Nice.
being taken up by proper professors and tenured scientists who then took some of these ideas, formalized them better, wrote papers using these ideas, that are given proper peer review and seriously considered as a valid contribution to the scientific literature. So it's been very exciting to be involved in that process over the years, and it's led to what we think is our ability, we hope, to be able to predict solar variation, which has never really been, nobody had been able to do that before, beyond a few years, as the sun came to solar minimum. Predictions could be made on the basis of what the solar polar fields were doing that might give you an idea of how strong the following cycle was going to be, the peak of the next cycle, maybe 5 years later. But trying to predict beyond that seemed to be beyond the possibilities. And yet, my merry little band of investigators got together, put some ideas together, looking at the motion of the planets and how that seems to mirror changes in the sun's activity in the past, and created an algorithm which would generate a model of future solar activity. We published that in 2013 in a journal called Pattern Recognition in Physics, which got shut down 2 weeks later by the behest of some IPCC scientists who wrote to the overarching publisher and complained, that we were contradicting what the IPCC was saying about rapidly increased warming, and that so our journal didn't deserve to exist, and so it was bombed from space and obliterated. And so, this is one example of the way that science now operates. Instead of doing what it should do, which is confront our ideas with better ideas and say, we think you're wrong because, and having a proper scientific argument, they simply censor things they don't like and sweep them under the carpet. Now, that's one example. Another example of chilling the debate that I've been through was back in 2011, when on December the 14th, I had seven members of the police turn up at my door with a warrant to search my house and seize my computers.
Amazing.
Because the excuse they were using was that they thought they might find something on one of my computers that might lead them to the identity of the person or persons unknown who'd liberated all the ClimateGate emails from the Climate Research Unit at East Anglia. But the real reason they did it was for intimidation, because I'd been publishing some of the emails and passing comment on them, particularly in relation to somebody who was not only a sort of leading light of the IPCC, but worked for the World Bank. And I was saying, follow the money. Let's look at what's really going on here. And obviously that high up person didn't like that criticism. And I think that led directly to the police raid on my home via a UK minister in the government at the time. Who obtained or got the judge to give the police a warrant. And now the amusing part of that story is it wasn't me who ended up in prison. It was that minister.
Okay. That's great.
Just instant karma. But there are serious issues with the censorship, the one-sidedness. The BBC, for example, supposedly a paragon of unbiased broadcasting, back in 2005, they convened a meeting of so-called climate experts who decided that there was no need to listen to the climate skeptics anymore, or give them any kind of platform for debate, because the science was settled. And it turned out that when they were asked for a list of those climate experts, the BBC refused to provide the list.
Oh.
And this was taken to the Information Commissioner by a guy called Tony. What was Tony's second name? I can't remember at the moment. And he made a Freedom of Information request to get these names. It was refused. The BBC wouldn't hand over the names. But then one of our community of climate skeptics, poking around on archive.org, managed to find the original PDF that the BBC had produced that had all the names on.
Oh, nice.
And what we discovered was that these so-called climate experts who decided that there was no need for a balanced debate anymore were in fact interested parties from campaigning organizations such as the WWF, Greenpeace, and etc. And so, this raises the question of who's really making policy, and why are governments giving money to these kind of organizations to lobby them to get the outcome that they actually want,
right,
against the interests of the population who elected them and who they're supposed to be serving. These are really big society questions that need to be talked about. And there are other people probably more able to talk about them than I am. So I keep trying to go back to the science, back to the things that really interest me. And what I love about science is, if you find something in the data that you can show to be true, then it doesn't matter what kind of arguments people bring to bear. It doesn't matter if they sweep it under the carpet.
Yes.
That truth will still be there in years to come. Be rediscovered and thought about, hopefully at a time when there's less contention, when there's less censorship, and so you are actually making some kind of contribution to science that could potentially lead to better outcomes for everybody in the future. So that's who I am and what I'm about. And I'm always prepared to defend what I believe in. And I believe that science has to be done properly. I believe that people deserve better from their elected representatives. And that this is something that we shall carry on making a big noise about, my friend, you and I, through every media that we can, because it's so important for the well-being of our fellow citizens and for everybody.
So who are some of your favorite scientists when it comes to looking at the solar effect on Earth's climate? Do you have anybody you could name, or like Willie Soon maybe, or?
Certainly Willie Soon. I was very interested in a paper last year that was published by a German scientist, Fritz Varenholz.
Okay.
And Fritz, is very meticulous in the way that he does his work. He downloaded all the data from the Ceres satellite. He showed that actually there'd been a reduction in the amount of solar shortwave being reflected back into space off the cloud tops, which meant there's less cloud. And this goes back to what I was saying earlier about more of the sunshine reaching the surface being the real cause of the warming rather than the increase in carbon dioxide. Because at the same time, the supposed heat trapping effect of the increase in carbon dioxide was actually allowing more long wave radiation back out into space rather than less. Now, the other side tried to explain this away and say, oh, well, that's because the surface has got warmer. So of course there's more long wave radiation going out. But my question is, well, why isn't it getting trapped? So what's the limit on this trapping? And they don't seem to want to go into that very closely. And they try to say, oh yeah, well, we already knew about this reduction in cloud causing more solar radiation on the surface, making things warmer. But that's just a feedback to the increased carbon dioxide. Now, as I say, there are things wrong with that. For one, cause and effect is wrong because you get more sunshine first and then increased temperature about 3 to 7 months later. So it's pretty clear which is causing which, isn't it?
Yeah.
And the other thing is that where they say, oh, our model's already predicted this. Yes, that's true, but only by having the models creating this, what they call the mid-tropospheric hotspot, which was supposed to be causing the global warming down at the surface. But when they actually went and measured it, looked for it, they couldn't find it. They could only find a very, very slight gradient in the order of, hundredths of a degree, which they then color coded in their diagrams in the IPCC report, blood red,
Oh, there you go.
to make it look like there'd been huge warming in the mid-troposphere, when in fact there hadn't. So, we're being gaslighted. We're being told
Yes. Yeah.
that that their theory explains all of this, and that it's the carbon dioxide that's causing all the warming. But the data says otherwise. And it's not just that satellite data. And if you'll permit me, I'll just go through a couple of the other lines of evidence which confirm the same thing about the reduction in cloud.
Sure.
So we've also, from the early 70s, got the International Satellite Cloud Climatology Project. It's a bit of a mouthful, so it's abbreviated to an acronym, the ISCCP data.
Okay.
And that also confirms that there was less low-level cloud, particularly near the tropics, after 1980. Then we've got a thing called the Earthshine Project, which measures the amount of light reflected from the Earth off the cloud tops onto the moon. And we can tell by the change in intensity of the light on the moon what the cloud albedo is doing. And that also confirmed that there was a drop in the amount of cloud after 1990. And so those two, coupled together with the Ceres data, and also very simple, ordinary sunshine hour counts done in China, done in the UK, all show the same thing, that more sunlight was getting through to the surface of the Earth at the same time, and then followed by more warming. So this is the reality. This is the climate reality that they don't want to talk about. And we have to make a big noise about this, because while they can't tax the clouds for not being there, or the sun for being a bit stronger than usual, they can tax people for emitting carbon dioxide, and are doing, and use it as an excuse to restrict our lifestyles, make our homes colder in winter, make us eat crickets instead of tasty morsels.
Yes.
And people should be quite rightly outraged about this, and throwing these people out of government at the next available opportunity at the ballot box. And so I think that's really sums it up really for our discussion, that we have to have scientific truth, we have to have open debate, and we have to have a correction in the way that policy has been formulated and is now being applied, not just in one country, but many countries across the world. Of course, there are some countries that aren't really going along with this, notably China, India, Brazil, Russia. And these people are going to, in fact, derive quite a big commercial advantage from all of this, and will probably start to overtake the West in some ways in terms of the standards of living of the people who live in those countries. And since they're not hurrying to reduce carbon emissions, the question arises, why would we, particularly in the UK, where we emit about 1/100th of the global emissions, even if we were to destroy our economy and leave ourselves with nothing and walk around in sackcloth and ashes, huddling together for mutual bodily warmth in the winter, we would make no difference at all no measurable difference to the Earth's surface temperature by going to those extreme lengths of cutting down emissions. So we have to have some balance in this debate. We have to have some common sense, and we have to keep talking about it. And thank you, for inviting me here today to talk about it at great length. And I'm going to hand over to you for the final word.
This is fantastic. Very good. One thing that gives me hope is I don't think voters anywhere are into the climate scam, in terms of no one is eager to give up their convenience or freeze or pay higher prices for gas. I think people are, to a virtuous signal, they'll say that they believe in it, but when the rubber hits the road, they don't. And I don't think, like we've seen that in the US as gas prices got high here, all of a sudden, Joe Biden was saying that refineries should do their patriotic duty and refine more oil. That's totally the opposite of what he was saying before.
Even the New York Times recently published a recently published a survey where they found that only 1% of US Americans thought that the climate was a top priority. And amongst the under 30-year-olds, it was only 3%. And amongst Democrat voters, it was only 3% too. And it always comes absolute bottom of the list of people when people are asked to put these 16 major issues in order of priority. It always comes at the bottom. There's a reason for that. People aren't stupid. They know when they're being gaslit. They know when they're being led up the garden path. The problem we've got at the moment is all the major parties in all the major countries are signed up to this. And so to end this charade at the ballot box, we're going to have to form some new political parties. What will we call them, Tom? The not zero party?
Not sure. But yeah, that makes me happy that the people don't believe it. Even after decades of just this white hot propaganda, they still don't believe it. And I don't know, they can't turn the knob up to higher. They've already turned the propaganda up to 11. No matter what, we're not going to believe it. So
that's right. And particularly young school kids, they see right through this stuff. You know, even though we're now into the kind of second, third generation of kids who've been brought up with this propaganda. They seem to see through it pretty easily when you talk to them, and have a healthy dose of natural skepticism as youngsters with freely inquiring minds. I think we've got more of a problem, honestly, with the sort of middle-aged generation, who tend to be, have become sober and responsible adults who've watched the mainstream news way too much for way too many years, and had their heads filled up with half the story. And don't realize that there is another half to this story that you and I and our other skeptic colleagues still carry on trying to get out there, because if you see it as the truth, you've every right to speak it.
Absolutely. All right. So this might be a pretty good stopping point, you think, for this time? I'd love to have you back if you have more time in the future and cover more of this stuff.
Tom. Love to. Thanks for asking me on today. It's been really great. And thanks for letting me speak at length about this stuff.
Okay. And then is there anything else the listeners should know about where to find you? I'll put the link to your blog in the show notes. Anything else?
Sure. Well, also I'm quite active on Twitter. Same kind of handle, at Tallbloke. ROG, which is a shortening of my first name, Roger. So at Rog Tallbloke on Twitter. Put that in the notes under the video as well, Tom, for me.
Very good.
And thanks again.
All right. Thank you very much. We'll see you next time. Bye.
All right. Thanks now. Bye.
Bye.